Do-do-do-do. Is this you? Are you that one kid that no one likes because he does not know his laws of motion? Well, fear no longer because I am here to teach you the ways of Isaac Newton. Law number one. Isaac Newton's first law of motion states that every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. To explain Newton's first law of motion more visually, let's talk about an arrow and arrow drop as an example. Before an archer can shoot an arrow, he must determine arrow drop between him and his target. Arrow drop is caused by gravity, and gravity is essentially the unbalanced force in the arrow moving forward. If this unbalanced force called gravity did not exist, the arrow would travel forever in a straight line until it hit its target. But since gravity does exist, the arrow is unable to travel forever in a straight line since it slowly loses height and slowly changes its direction pointing downwards. Law number 2. Newton's second law of motion states that the relationship between object's mass and its acceleration and the applied force is force equals mass times acceleration. Acceleration and force are vectors. A vector is a quantity having direction as well as magnitude, especially as determining the position of one point in space relative to another. To explain Newton's second law of motion better, let's use a rock as an example. No, not that rock. This rock. We can use pulling a rock as a great example to explain Newton's second law of motion. To do this, we can compare pulling a large rock and a small rock. If we were to pull a large rock that weighed 800 grams at 10 newtons of force, our acceleration will be much smaller than if we were to pull a small rock which only weighed 100 grams at the same 10 newtons of force, which would have a much higher acceleration. Law number 3. Newton's third law of motion states that for every action there is an equal and opposite reaction. As an example, let's talk about a canyon. When the canyon fires, the cannonball being fired exerts an equal force back at the cannon launcher, causing both the cannonball and the cannon launcher to move in opposite directions. Congratulations, kid. You now have the facts and knowledge to fit in with the cool kids.